everybody. Mike Levin, Saturday, September 17th, 2022. In the car on the way to the Poconos to do one of those pickups from storage, and I thought I'd get one of these videos in. It's been a while since I've done a driving video. It's becoming long too since I've done time-stamped videos, verbal time-stamping, because when I do the talking head videos, sitting at the computer doing the screen recording using OBS, the open broadcast software that I've recently switched over to, you gotta jump right into it. The attention span for the people on that stuff is so limited. Here I've got Zero, Nova and stuff. I mean, you'll listen to me no matter what I talk about, and it doesn't matter how I begin. But over there on the talking head and coding side of things, if you don't grab their attention instantly, they're surfing away. So I start recording and I go right into it. And so much to talk about. The longer the time period between videos, probably the more I have to talk about and the more easily and fluid I can get into the subject matter, which this time is running Jupyter Lab under the LXD Linux container system, under the Microsoft Windows subsystem for Linux, a WSL system, naturally under Windows. I'm using Windows 10. It'll work under Windows 11 just as well. And it's a big deal, and it's gonna have to percolate for a while. These videos I roll out, and they're somewhat timely, somewhat perishable, because things do change. They gradually shift and change, but that's almost exactly the point. I try and jockey and position myself into areas where the APIs don't change that much, to where the APIs are not visual, right? Because visual APIs change a lot and require a dramatic retraining of your muscle memory, how you move your mouse or trackpad, what you click, where things are. Whereas a reworking of text-based APIs, typing in the command line interface, changes somewhat more gradual. Whether or not a sudo is required before an LXC command would be an example. And the more you get yourself onto the command line for the important things, the less disruptible you are, the more future-proofed you are. So my emphasis has really been on quite a bit of future-proofing on the command line side, on the Linux command line side, and generally under Windows still. I get a lot of feedback. Why Windows? Why struggle with all this stuff, Mike, when you can just install Chrome OS, the new Flex Chrome OS system? And you know what? That's just about making money as much as it is on the Windows side. You go ahead and install Chrome OS Flex and watch them try and promote and market themselves to you, to try and get all your enterprise business, to help with the whole switch over to the cloud. Is starting in Google Suite, G Suite. It's the sweet spot, right? SUITE, SWEET. G Suite is the sweet spot. And once they get you hooked onto web-based software, and they gradually, decouple all those hardwired connections to the Microsoft hardwired backend API, and you're living mostly in the web browser, then why have Windows back there? And so that's what Chrome OS Flex is about, the USB installable thing that came out this summer. I'm still going to do videos on it. I've started experimenting and kicking the tires. But you're off in your lonesome if you choose a Linux distro that's not mainstream, where some big vendor's trying to make money off you, right? So it's a trade-off. You give a little, you take a little. You concede to the fact you're going to be on Windows, and you get back a platform that frankly has the most polished desktop out there. I mean, people might argue that, but with the exception of a few little nooks and crannies you can still find, like changing certain things about your mouse. The setup program will expose some of those ancient UIs. Wow. So many of these drivers. I got a death wish. for the most part, Windows 10 and up is a highly polished user interface. And it's not about the desktop for me anyway, so why put yourself out in the wilderness with some Mint or other Linux desktop when you can just be on the great mainstream one and be in sync with everyone else? When you talk to people, when you share links, when when the common experiences between you and them are important, i.e. staying compatible with the Office, you've got it all. You've got the familiarity with what the world is using. And likewise, when you're doing server stuff, when you're, apt installing and getting the latest TensorFlow libraries and PyTorch, and you're doing your machine learnings and your AI stuff, you want to be on Linux with access to your GPU. And if you're not one of the cool kids, let me tell you, no matter how much people might shame you into Windows, shame you into using Windows, being a Windows person, the opposite is just as true. If you're on the bleeding edge, or even not on the bleeding edge and just doing server stuff, automated stuff, if you're not on Linux, then you are as uncool as not being on Windows is to the, mainstream crowd. So it is true you can get the best of both worlds with the Windows subsystem for Linux. Microsoft did a good job. And they're taking advantage of things they put in place with NT years and years ago. So NT stands for New Technology or Next Technology, something like that. And it is even more modern, significantly so, than things like Unix that I advocate so much. Well, Mike, if NT is so much more modern than Unix and Linux, why advocate Unix and Linux? Well, because the ways in which NT is modern is not the ways in which you use, or I use, a computer every day. It is in having a protection racket, I like to call it, a protection ring, protection racket. However you look at it, it's ways that you can isolate running code from each other, where you need really difficult to achieve permissions to muck around with it. And this is really good for running, say, two things side by side under Hyper-V, right? NT is the perfect operating system. NT and things derived from it, which is up to Windows 10 today, and all of Microsoft's products now. Everything after, I'm not sure. The switch over server side, I believe, was NT and Windows 2000, and consumer side, I think it was by Windows 7. Vista might have been the first one, but they botched that so much, so they rushed along to Windows 7, and then Windows 10 really hit it home, and then Windows 10 started to regress, becoming too markety, right? Windows 10 with the blue cloudy Windows screen, the really rich blue light coming in from the right hand side through the Windows logo, that was to me just such a sweet spot. I used the background of that in black and white in my personal logo. I liked that version of Windows so much. Then they flattened it and went more IKEA in design. So anyway, I digress a bit. The NT technology that's so great is the ability to run piece of code A next to piece of code B without those two being able to touch each other or know about each other, with the common resources being divvied out and shared, and without it causing much problems or performance degrading, right? NT does that stuff well. So this is why the Windows subsystem for Linux runs so very well. It's using these NT technologies and the rings of protection to keep things from stomping all over each other. This is why I use the word ziggurat a lot lately. If you look at those Mexican pyramids, those are ziggurats, the ones in Peru where there's level built on level, but instead of a smooth triangle up, they are these quantized steps going up, like stair stepping. And when you're talking about virtual machines and containerization, those ziggurats occur with the lower, larger platforms being the outer, and with the higher, smaller steps being the inner. So it's tempting to think in terms of virtualization, where each step up you take a major performance hit, but it is not so anymore. because of NT isolated kernels, that kind of stuff, and Hyper-V, those steps up don't always incur a performance hit. It's really, truly amazing, which is why I can construct a ziggurat, which is at the base Windows. As far as the user is concerned, there's even other levels going on here, but as far as the user is exposed to, you log into your laptop or desktop or whatever, and you got Windows 10, say, for instance. You do WSL space -- install, which I highly encourage everyone to do. You've now got the Linux subsystem for Windows subsystem for Linux, WSL. And that's the next ziggurat step up, right? Now, in my recent videos, I've been doing one more step up even above that with the LXD Linux container system, something that came out from Canonical, the same people who brought us Ubuntu. So there is a big commercial version of Linux back there, right? You're still in kind of commercial land with this stuff. But because Microsoft chose Canonical as the default Linux for Windows subsystem, you know where Canonical's making their money. They are a major Microsoft partner. It's pretty astounding that Microsoft has not bought Canonical, but that would trigger off such a rigmarole, such a fuss, stirring up the hornet's nest, that Microsoft isn't going to do it. But you can rest assured that Microsoft is Canonical's biggest customer and will take care of all the difficult driver compatibility issues that are going to come up. They are highly incented to do so, and you can be the benefit of all that, the beneficiary of all that work. More so than just on using Ubuntu, on using LXD, a container system to create that next ziggurat level of Linux, the next ziggurat level of virtual hardware. Better than virtual. Virtual implies emulation, but it's not really. I mean, it's not necessarily. Certainly many of things called virtual are doing emulation, which has a busy level where things are translated between things. And it's what QEMU is so good at. It's why you can run Android software on a Windows desktop. It's because QEMU is an emulator and is changing the low-level machine instruction sets. So containers tend to not do those emulation tricks. Containers tend to just pass things through with a very lightweight mapping. They're still mapping. You're not going to get away from mappings. But instead of translation layers where several machines instructions are dedicated to changing machine instructions, here is some machine instructions saying that this stuff coming from an ARM processor has to be changed into this other stuff coming from a x86 processor. That's where the performance hit is incurred on emulation. On virtualization, it says, oh, this machine instruction over on this hardware is this same exact machine instruction over there on that hardware. In fact, if they have the same addresses, indexes, the translation is 1-to-1. It's like a WildStar redirect on the web. Anyway, you get really, really fast performance even as you go up the ziggurat. And that's what's happening with Jupyter Lab server under LXD, under WSL, under Windows. On that last video I just put out. With each passing video I put out, I think it's the best video I ever produced. It's no take. Some of you would wish it was no take. With one take mic, right? I don't like to edit. The 80-20 rule. I live and die by the 80-20 rule. Life isn't fun if you're doing 80% of the work to get 20% of the benefit. Now, I feel like I do that a lot, projection, right? So I talk about this a lot because I'm guilty of it, right? Whenever you hear someone accuse someone of something, call them names, for example, they are revealing what they most think and fear about themselves. They are revealing their deepest insecurities 80% of the time. So when you find yourself violating that rule yourself, spinning your wheels, such as it were, putting too much energy in for the benefits out, what you do is you back up and you refactor, you re-examine the situation, you back up out of the rabbit hole. You just dived headfirst into a rabbit hole. You might not have realized it. So what you do is when you dive into rabbit holes, you leave a rope, a rappelling rope. You rappel into a rabbit hole, and when you've made a mistake, you can climb back up out of it and back off a little and ask yourself whether you want to go back down into that same rabbit hole again, perhaps more prepared, or bypass it entirely in favor of another solution, another approach. And you know what? I encountered that several times trying to get Jupiter to be hosted under LXD, under WSL, because it's so much more easily accomplished hosting it directly on WSL. Maybe even a tad faster. So why not? Why not go that route, Mike? Why have the extra ziggurat level? It's because you're fighting back against corporate mind control, my friends. You're fighting back against subtle manipulation, my friends. And you accuse someone of something, you're guilty of it. Yes, I'm using mind control. I'm using Cialdini's, principles of persuasion to help you future-proof yourself, to help you get off of that rocking, storm, beaten boat, ship, deck. You are on the roughest waters that exist when you're on proprietary visual software, because it's going to change, because the platforms change, because the vendors need to make money on a quarterly basis, because features are gratuitously added to create fear of missing out. What is that? Not FUD, that's fear, uncertainty, and doubt, but FOMO, fear of missing out. So Adobe dangles the carrot in front of you, throwing in the next, feature that you don't really need. You could get along with GIMP from the free and open source world just fine if you didn't need auto magic AI-powered background removal on traveling mats and stuff like that. I mean, cool stuff, useful. But it'll all be Python scripts under GIMP, and if not, Python scripts under Blender, right? So my friends, you don't need to be yanked around by vendors. What you're doing, everything is mind control. Everything is brainwashing and indoctrination. The social contract being raised up by modern society so that you're a functional adult is just the more approved brainwashing program, right? We are programmed. We are not born as fully capable creatures. Walking and language are probably the two best examples. Holding your head up when you're born. So a lot of critical learned behaviors, a lot of critical behaviors of being a human animal are learned. Some of them you just pick up automatically, but with decreasing amounts of automaticness. Holding your own head up comes pretty naturally. Crawling and then walking, again, pretty naturally. Talking and language and this whole spoken side of the equation, pretty naturally. Written, if you don't make a special effort, you're illiterate. There's a fuzzy line of demarcation between those things you will pick up automatically and those things that take effort. How much effort? Well, most people in modern society become literate. Am I right? I don't know. Maybe they do. Most people learn how to read and write. So the fuzzy line is in math. Math, numbers, zone out. I'm guilty of it myself. I never made that transition and became a math person. And now at 52 years old, I'm making the attempt. I think it's a worthwhile endeavor. It's just another language. And just like a written or spoken language, it takes practice to get better. If you don't use it, those muscles atrophy. and you lose those abilities. Certain maths are easier to come back to because they are more natural in your brain. That is the same with coding languages. I have left and come back to coding languages with year downtime intervals many times. Certain languages are easy to come back to, and other languages are nearly impossible. Java, not JavaScript, but Java was nearly impossible. Public static void null. I could not come back to Java after periods of being away from it. JavaScript I could a little bit more, but boy, were things different between each year interval. Not easy, my friends. And that was before Node. I was on JavaScript since Netscape Enterprise Server 98, 99. Last millennia, my friends. JavaScript is not new on the server with Node. Node just made it popular of late. And even that's a moving target. What are they up to? Version 18, 19 after just, 3 or 4 years, 5 years tops? To have nearly 20 versions in 5 years, 5, 10, 15, 20, that's 5 versions per year. You have to adapt, and sometimes there's significant changes, and you have to refactor your code. And if you're not getting those radical disruptive API changes in the Node side of it, then you're getting it in the framework side of it, going from Angular to React to Vue to Svelte. This is not easy, even when your APIs are command line interface side. There is a certain volatility you want to avoid. Now, people criticize the Python community for the horrible tear and rift that existed in it, going from what was essentially Python 2.6, the last major deployed version, so good that people didn't want to upgrade their servers. If it ain't broke, don't fix it, right? That's Python 2.6. At the 0.6 versions, that tends to happen in the Python world. 3.6 is shaping up to be one of those. They're up to Python 3.10 now on the 3x side. But 3.6 has become the, settled upon version. Most things do 80-20 rule. The 80-20 rule is satisfied at the 0.6 versions on Python. You get 80% of the benefits you're looking for from that next major upgrade, with 20% of the maintenance and upgrade pains. 80-20 rule. 2.6, 3.6. But the point I'm making is going from 2.6 to 3 point anything almost tore the Python community apart. That one level of upgrade from a major, where APIs are allowed to change, where prints needed parentheses around them because they were no longer a, interpreter keyword, and now we're a proper Python function, and functions have parentheses. That kind of thing, and upgrade scripts, Python 2 to 3, stuff like that, 6, libraries could just do those changes automatically. It wasn't even a big deal with like 99%, success rate. So the pain level was really truly small. The biggest pain was going into code you don't want to touch because it ain't broken, don't fix it, right? Fear is what caused the rift in the Python community, not the ease of upgrade. Who wouldn't want Unicode? And now the reason to go to 3.x is performance, right? So they really locked API volatility down. They said, don't change big things and work on improving performance. And so Python, whoever they are, the people who are the benevolent dictators now that Guido van Rossum stepped down from that role, are cautious, still reaching. They're not cautious to the point of paralysis, and they're still reaching, just not overreaching. And wise. If you're looking for wisdom, you look for Python. And wisdom says APIs change gradually over long lifespans. So in the 20-some years, is it 30 years? Python came out, 91? It was a big year for technology, around 91. No, that was Linux. Python might have been 96. I don't know. But anyway, you measure it, even if we're in 2022. If you say 92, 2002, 2012, 2022, that's 30 years. So give or take 5 years. Python's about 30 years old. In those 30 years, they're up to version 3. One major upgrade per decade, my friends. This is part of the formula for future-proofing yourself. Someone like me who likes to learn, someone like me who can't help but to learn slowly, but to learn well, finds the constant disruption churn in most areas of technology disturbing to the point of not worth it. Sorry, you're going to have to deal with my air conditioning a little bit. I'll keep it the lowest I can. So I'm on a Jeep. It's 2013. I had the option of getting a 2014. I believe I have the years right. It's either 2012 to 13 or 2013 to 14. But I had the option of going to the first year where there was significant dashboard electronics. I said, no thank you. I will not be a year one adopter on that. Jeeps are timeless designs, as it were. It took German ownership. It took Mercedes-Benz temporarily owning Chrysler to do a major upgrade design and improve the quality, to make Jeeps genuinely better, to the point where Jeep aficionados don't go, yuck, I'm out. So, while the people who the Jeeps helped defeat owned it, they actually improved it. Now, they didn't hold on to it, and I find it a redeeming quality of Jeep that they're not owned by the Germans anymore, but they're actually owned by the Italians, who, Mussolini wasn't much better, does live on the vibrating edge of, whether they're good guys or bad guys. Italians are okay when it comes to political alignment half the time. They've got a pretty, deep history of being in that role, going back to the Romans, who were, of course, copying many things from the Greeks before them, right? The Romans did a lot of copying, and such as it is today. So it's a really interesting company, this, I think it's Fiat Auto Holding Company, who currently owns Jeep and the Wrangler. I'm not talking about these Cherokees and these other non-Jeep Jeeps. Oh my God. So how many people I am insulting, right? Let me talk about Nissan Altimas. No, anyway. Jeeps have this API issue in a large degree and maintains this nearly fanatical loyalty, because no matter the churn, no matter the ownership of Jeep, they appreciate what's special about it sufficiently to not destroy it. They do not change the API too frequently. There's a weird thing coming up on my left. I'll go over here so it can pass me. Watch out my window as this thing passes me. What was that? Two wheels good, four wheels bad. Three wheels? I don't know. So, unchanging APIs. So, reality, APIs are not going to be unchanging. You're not going to get completely static APIs, nor do you want them. You want to be dynamic by tiny degree. Be dynamic, decade by decade, on your tools. How often have samurai swords changed? Once they got nano fabrication technology down in the ancient times, I kid you not, samurai swords used nano fabrication techniques down at the molecular level. Samurai swords are manufactured, and they've been doing this for hundreds of years. I don't know if I can say thousands, but certainly for hundreds of years. The right ratio of pure iron was mixed with pure carbon and a couple other metal alloys, and it was hammered and folded and tempered and heated and hammered and folded and tempered and heated so many times that you can see a wavy line. There's a name for it, but it's a wavy ridge line going down the edge of a samurai, going down the flat surface of the samurai sword. That is a 1 atom thickness. If you want to see 1 atom thickness, that's one thing you can do. Fold yourself some steel. The folding process gets things down to the 1 atom thick sharpness. And maintaining that sharpness because of the alloys and the carbons and stuff that are in there, resisting rusting when it gets wet. So these are good solid techniques for tools. And when you have a good, solid, timeless technique for your tools, you stick with it. And you gain the benefit from it, and you walk away from the benefits of alternative tools, which, while might offer a few more bells and whistles, violate the 80-20 rule on several fronts. They make you more dependent on the person who provided you the enhanced tool. The enhanced tool, with its bells and whistles, is itself more subject to change than more traditional tools, so your need to buy the next version of this bells and whistles tool is higher, greater. You will need to buy it more often because it does not have the time-tested craft put into it as have the crafted tools. They break more often and further fuel your need to upgrade and to pay the original tool provider more often. This plays right into the desires of the tool provider, the vendor, who wants to make money off of you and rely on a certain amount of income each year off this new tool. So it is in their interest to design the breaking and the feature obsolescence directly into the tool. Designed obsolescence. It's a real thing, and conspiracies do exist. Google on the light bulb designed obsolescence conspiracy. Light bulbs from about 100 years ago could have been given a 100-year lifespan, but it was the main way that General Electric and companies like them, I forget the light bulb companies back in the day, I might be wrongly accusing GE, but they're guilty of plenty of things along these lines, needed people to keep replacing their light bulbs, so they made the filaments burn out faster, reliably faster. They designed obsolescence. This is present in all tools. Up until recently, when spearheaded mostly by one individual, Richard Matthew Stallman, RMS, still alive, one of the great grandparents of modern technology, did a few things. Copied the proprietary tool, Unix, command for command, and made the GNU is not Unix, the GNU version of the Unix commands. So he had a command set, but no bootable hardware to run it on. The bootable hardware comes from a piece called the kernel. The kernel is not the full operating system. It's just enough low-level Frankenstein code to give it life when you pull the lever and send electricity into the machine. Whoa. Two wheels bad. Here comes another. Ready? Not quite as fast as the first two, but the Death Wish Brigade. Anywho, continuity of thought. Don't lose your train, Mike. You can always get it back. If you are talking about something important, designed obsolescence, it was designed in modern tools, Unix. Unix was copied as the GNU command set. The GNU command set can be gotten down to like 500K on BusyBox Unix. There's versions of this that get this down to a floppy disk size, half a floppy disk. And then the Frankenstein, pull the lever, get life into the machine, that's the kernel. That is actually what Unix is, and more frequently in modern days, although not so because of micro Linux, is Linux, micro Unix. So every modern computer has at least two operating systems on it. It's got a micro version of Unix so that Intel and AMD can log into your machine remotely and take control of it to maintain it. This is why shutdown and restart happen so quickly. This is why so many of the problems of yesteryear, combined with the NT technologies, and taking advantage of the NT technologies, because NT makes it easy for a parallel operating system to be running. So what if your parallel operating system is a teensy tiny little Unix with a full network stack, with its own MAC address, with its own TCP/IP networking layer? So your machine is never really off. It can be connected into by Intel whenever they want to, with root level privileges. So every modern machine has at least that micro Unix installed. From Andrew Tannenbaum. I kid you not, Google this stuff. Andrew Tannenbaum, micro Linux. I think they're up to version 5. It's on your machine. Intel management console, something along those lines. And then it has, of course, your Windows, right? So Unix plus Windows is already on your machine. So by the time you're installing the Windows subsystem for Linux, you're up to your third operating system. It's a lot of overhead. You should go with a Raspberry Pi. That way you just have one operating system. You should at least know how to do that. All right, so Richard Matthew Stallman reverse engineered the Unix, the proprietary at the time Unix commands, made the bizarro parallel GNU is not Unix, the GNU versions of those commands, and combined together with Linus Torvalds' kernel, and you have GNU Linux. You now have the free and open source movement. You now have the samurai sword of tech. It's an elegant weapon from a more civilized time. Do you get it? You can build it yourself. Linux from scratch. You should Google that. Oh my God, people. You're not a technology person if you haven't at least considered Linux from scratch. You're not a technology person if you don't know how to get one and only one operating system running on your hardware, which is only possible on things like Raspberry Pi these days. Even if you install Linux on your laptop or Chrome OS using the Flex USB keychain, you're going to still have that Minix back there. You ain't getting rid of Minix. But if you start with such small hobbyist-oriented hardware like a Raspberry Pi, then you'll have hardware that just has one operating system. And you'll still get a desktop and a full network stack, and you can still use it like a modern computer. This and more you'll learn from me and my channel here. Sure, I'm on a Windows laptop most of the time, but that's because, hey, yield to the mainstream. Yield to the mainstream on the desktop, run Windows 10 or 11. Yield to the mainstream server side and run Linux under the Windows subsystem for Linux, but cleanse it of its kooky APIs. It lacks systemd, the modern way to run Linux services. You need Linux services in a modern sense. You need systemd. So you put systemd back onto Windows subsystem for Linux. WSL plus systemd by way of something called distrod on GitHub. So just Google distrod or possibly distrod space GitHub and you'll find it. Run their install scripts, enable the service, and you have systemd on Windows subsystem for Linux, and now you can get started. But you don't use that directly. With systemd in hand, you can create the next ziggurat level up or down. Would it be up or down? I'm not sure. But at any rate, because there's no big performance hit, in for a penny, in for a pound. Use the same trick that lets Minix run as the invisible hands in the background, using the same technology that lets you recover from botched Windows installs pretty easily, using the same technology that allows the Windows subsystem for Linux to run as a separate but equal kernel next to Windows. Use that technology to make your fourth operating system, ladies and gentlemen. We're up to operating system number 4. There's Minix, there's Windows subsystem for Linux, and then there's LXD that comes from the aforementioned creators of Ubuntu, Canonical. Canonical sponsors the LXD, free and open source. It's peeing the pool, it's internet not coming back, so don't be bothered by the fact that they are flooded with money from Microsoft. Embrace LXD as your fourth operating system and probably third ziggurat level, because you're not running on Minix, you're running on Windows, and WSL is running on. So with WSL, even though it's a side-by-side kernel, all the administrative tools come through the Windows side, WSL.exe. So ziggurat-wise, the base is Windows, let's call it 10. The next level up, the next stair-stepping on this Peruvian pyramid is WSL, the Windows subsystem for Linux. In my case, 18.04, because it's the easiest one to get systemd running on, and the easiest one in turn to get LXD running on. And then you go to your third ziggurat level up as an LXD instance of Linux. I use Ubuntu 20.04 because just because you're compromising with an older version to get LXD running, you don't have to compromise on the container. So the container on LXD is actually a newer version of Ubuntu than the one that's hosting it. 20.04 under 18.04. Or over, if you're thinking those ziggurat pyramids. And that brings us to the end of the story. It's a nice story here. One of my best video talks in the car, my best driving talks, because I think I'm really drawing a picture of why it's okay to have 4 operating systems running simultaneously on your laptop with a ziggurat pyramid of 3 of them, so that tippy top one is providing Jupyter Notebook server. You have whitewashed the strangeness of Windows subsystem for Linux. The systemd that exists on your LXD containerized Linux has not been specially installed. That came down with the image. So when you do LXD space launch space Ubuntu :20.04, you're getting as normal a Linux as anyone else out there in the world who is not actually sitting on a Windows laptop. Your systemd is the same systemd as people who are running on native Linux, Linux on the hardware, Linux on the metal. So you've got a Linux instance which has pretty good performance that runs with, nearly on the metal performance that doesn't have any compromised APIs like the WSL one does, right? Windows Subsystem for Linux has compromised APIs. The non-inclusion of systemd is the biggest violation. There are others. But once you get past that one biggest violation, the 80-20 rule kicks in, saying, once you have systemd running, you can get LXD running. Once you have LXD running, you can get a standard Linux. Standard Linux, all knowledge and know-how you develop at the top of that pyramid on the most inside version of Linux you can run. You are future-proofed. You are resistant to disruption. You are a samurai warrior of tech. You are using a more elegant weapon from a more civilized time that has been able to be transported forward in time thanks mostly to the efforts of Richard Matthew Stallman and Linus Torvalds. The original weapon design on the proprietary side was developed by Ken Thompson, also still alive. God bless him, right? So all three of these people, Ken Thompson, Linus Torvalds, and Richard Matthew Stallman, still alive. They're not national treasures. They are world treasures, ladies and gentlemen. It is a miracle of the modern age that these tools exist and that the people who created these tools are still walking this earth. The brain drain super suck is at work for them. Linus Torvalds, I think, works for him, so he's still independent, but on the Python, Microsoft hired Guido van Rossum. With Ken Thompson, Google hired him. He created the Go language, which powers most of Google's infrastructure. So, together with Rob Pike and some other people, once again, Ken Thompson didn't modernize the world once. Ken Thompson modernized the world twice. You have much of the performance of the modern cloud to, thank Ken Thompson twice over, bypassing Linus Torvalds almost entirely. I mean, thank you very much, Linus, but didn't really need you. He just popularized a lot of this stuff in the mainstream by giving Richard Matthew Stallman, who made the command set, the magic little piece that let it actually come alive on hardware, the Frankenstein It's Alive electricity switch. That came from Linus Torvalds, low-level kernel stuff. You wouldn't know Linux if you saw it. You think you do, but you don't. You know GNU command set when you see it. It's all RMS, Richard Matthew Stallman stuff that gets visually exposed to the user on the command line. So, the modern samurai sword exists. The modern lightsaber exists. It got teleported forward in time through the efforts of people who got it into the firmly free and open source. How is it firmly free and open source? So Richard Matthew Stallman did not only create the commands or, reverse engineer the commands, the Unix commands from the proprietary land, things like CD, PWD, LS, all those, short little commands you type in the command line. Not only did he reverse engineer black box all of those, but he did all the legalese. He did all the lawyering stuff. So once the P got into the pool, the P was not coming out of the pool. The pool could not be drained. Richard Matthew Stallman's true brilliance is not in copying the C/Unix stuff, which by all rights he should despise because he's a lisper. He comes from the alternative, bizarro, older, earlier, and failed lineage branch of technology called Lisp. Lisp operating systems, Lisp language, Lisp hardware. Boy, if my heart was broken by the demise of the Amiga by coming into Commodore's grip, then many more people's hearts were broken, or people of, higher computer science pedigree and more ancient during the times when this stuff was really being formulated, their hearts were broken by the demise of Lisp. Lisp, which hangs on with a, zealot-driven fervor as much as the Amiga is, as much or more. You'll still find common Lisp put down by Michael Kennedy, but nonetheless, as powerful as it's ever been. Advocated by Paul Graham, the creator of Yahoo stores, which systematically fell into, obscurity, which tells you a lot, right? Just because you do things first and best does not mean it will be the survivor in the long term, because other things that get different things right, that end up making all the difference, can be more important. They add viral components to new technology. So Unix, with the cross-machine compiling tricks borrowed from BCPL, an invention of not Ken Thompson, an invention not even of Dennis Ritchie, the inventor of the C programming language, but it came from another guy, a Brit, whose name I always forget. I really have to get it down. It came from Cambridge University, not Massachusetts, but the UK. Cambridge, Britain has a technology school. Martin Richards, I'll get it eventually. But they got down the principles that were in BCPL, which made cross-hardware compilation possible. Ye old virtual machines. Virtual machines at the compile stage, not at the runtime stage. So Java popularized virtual machines at the runtime stage with the Java runtime engine, the JRE, copied by Microsoft as the Common Language Runtime, the CLR, where they got their acronyms reversed. It should be the Common CLR, but they couldn't use CLR because that was already used for clear screen on some systems, so it had to be the other. So Microsoft just reverses its acronym letters around, but copies it from someone else first. So the fact that BCPL got the virtual machine trick down so that you could compile it for hardware A, you could compile the same program for hardware B, and while the executable was not transportable between hardware platforms, the source machine code was and could be recompiled. You just have to move the operating system in the compiler, and all the software follows along. That's why the C-Unix 1-2 punch combo beat the heck out of Lisp. One highly opinionated and highly prescribed way of doing things that scratches the most serious itch and abides by the 80-20 rule. Bammo, whammo, Unix/C, C/Unix. And even Richard Matthew Stallman knew this and saw the wisdom of this and left his Lisp camp, in which he was very dedicated. He even created a company based on Lisp. Symbolics was created at the same time. This was the genesis of some of this hardware that led to, Jurassic Park graphics. But that faded away because the 80-20 rule applied to x86 hardware. Righteous feedback loops of improvement, of technology improvement. Intel's tick-tock, relentless driving forward of the state of the art. All this stuff kicks in and you get these righteous feedback loop virtual cycles that makes lots of money for lots of vendors, pushes the tools forward very rapidly, and brings us the modern age. Is it all bad? No, it's not all bad. It brought us the modern age, and it's going to continue to bring us the modern age. There is a very important role for proprietary, for, commercially incented systems. They're not going away. They're just not the pea in the pool of tech. They don't have the great unchanging APIs. The stuff that was created around 1970 through the 80s, it stabilized. System 5 Release 4. And then all this stuff, the Samurai Sword, exists under proprietary systems like Microsoft NT, new technology. So you can have a little Unix here, you can have a little Linux there, you can get up to 3 or 4 of them on one machine and you don't even notice it. It doesn't even degrade the performance of each. You have Microsoft proprietary NT technology to thank for that on a modern laptop. I think it's even better implemented than the way these things work on the Mac. I was on the Mac with VMware Fusion for a long time. My 2011 Mac still very handily runs Mac OS Sierra plus Windows, say, XP, plus Ubuntu, say, 16.04, maybe 18.04. I'll set that machine up doing this again. And then on each one of them, so you're already three desktops, 3 separate OSs. On each one, I boot Linux. Linux on Windows, XP, Linux on Ubuntu 18.04, and then Linux again on native Mac desktop. So that's, and in these days they didn't have Minix on these machines. So that's 1, 2, 3, 4, 5, 6 operating systems on a 2011 Mac. I'm going to do that demo again while I'm screen recording it with ScreenFlow, one of the best screen recording software things I ever got. So sometimes you freeze and pin your versions at these magical moments that exist. So I know what I'm talking about. I saw Type 1 and Type 2 virtualization when people had to talk about Type 1 and Type 2 virtualization, when Type 1 virtualization on servers cost you $30,000 for VMware ECS, I don't know, EMC, some version that, was denied to me when I needed it. And I couldn't even get the slightly less versions. I was relegated to the VMware player that had no way to auto restart it. And my work looked really bad because, when memory blew up, they popped like soap bubbles, but that's water over the dam, water under the bridge, and a big you-know-what to you-know-who. But I moved on from that. I've healed. I've learned and experienced Type 1 and Type 2 virtualization distinction going away in favor of everything's Type 1 because Hyper-V. Because of these virtualization features built in at the chip level, at the CPU level, greatly because of multi-core. How can you take advantage of multi-core? You can't have flaky operating system software not knowing what's what with multiple processors underneath. It's going to botch it every time. It's going to foobar it every time. So an almost operating system had to be provided at the operating system level. That's why arguably it's your 5th operating system. Hyper-V is kind of like an operating system. But it just slices and dices and delegates and isolates all your multiple core capabilities. Even on a single core, it can slice and dice. It can do this stuff. It's called Hyper-V, and there's different versions of it. That's kind of the marketing name of it from Intel, but it's just an overseer of low-level hardware resource allocation so that virtualization tricks can be pulled off at seemingly higher levels with a greater level of performance and stability than anyone ever thought possible. And I should wrap this up now because we're coming up on an hour-long video. And so these are the things I'm taking advantage of to make Jupyter Lab server run on LXD, where we whitewash all the strangeness of the Windows subsystem for Linux, even though we take advantage of the Windows subsystem for Linux, to host an LXD container by throwing systemd onto it and doing a little bit of hocus pocus. This is all spellcasting, my friends. This is all learning magic. And over the 1 hour point of the video here, I will admit, on the spiritual kooky side, I'm spellcasting. I'm a good spellcaster. I cast very powerful spells. Certain spellcasting languages where the most powerful spells are possible, I don't like those languages in those environments. That mostly rules out the most powerful language of all, second only to Lisp, C. I am not a C person. Even ISO SQL 89 with like 40-some commands. 40 commands. You can learn 40 commands, Mike, but yeah, then you have to write all your housekeeping. Oh, who likes to clean their house? So no, 80-20 rule says Python. Python is my programming language of choice. When I have to hold my nose and use something other than Python, I'm holding my nose and using Bash script. You thought I was going to say JavaScript, didn't you? Well, JavaScript too. I hold my nose and I use JavaScript to do Puppeteer automation and things like it. I hold my nose and use Bash script to create the WSL2LXD installer that previous video is about. I hold my nose and I cast spells in spellcasting languages that are not quite my favorite. Not quite my favorite. Python's my favorite. But I'm casting spells nonetheless. And to prove to you my special mojo, my unique touch, Google Linux and find the respin. You can hardly call it a distro, because I didn't write my own distro of Linux. I plucked the involatile, immutable, init RAM-FS core from Tiny Core Linux, the heir to damn small Linux, DSL. If you ever used business card Linux in CD-ROM days, you put this business card shaped CD-ROM into your CD-ROM player and bam, you had Linux. That was damn small Linux, DSL. DSL Linux got split into over politics. The more powerful side of that political schism created Tiny Core Linux. Richard Shingledecker. You should Google him too. Interesting personality. He's no Richard Matthew Stallman, but he's along those lines and uncompromising. Right? If you don't beat him with the reverse engineering someone else's work, then you beat him with the legalese surrounding it. These are special breeds of people, my friend. Richard Matthew Stallman and Robert Shingledecker. I think I called him Robert Shingledecker. Just Google Tiny Core Linux. So I plucked Tiny Core Linux's core. I plucked QEMU's most stable, most popular binaries for each platform. So I got the EXE for Windows from some Japanese site where it was most popular. I got some EXE for Mac. It might have been the Q project initiative, somewhere or other. The most stable compiled QEMU executable existed. And then I got one for Linux. I might have compiled that one myself, I forget. But then I did a magic cocktail mix so that with a double click of a .vbs file, you got Linux on Windows. With a double click of a package, a bundled app package on Mac, the native version, the way it was distributed, you got that same Linux. If you saved stuff, if you had work on it, and when you left Windows, that same work was there when you went to a Mac one. It was amazing. It was a Noah's Ark of Linux. And then if you quit that and went to a GNOME or a KDE desktop, and you brought it up there with a double click on the .sh file, there was your work. Persistence of a double-click runnable same version of Linux across radically different desktops, operating systems, and in some cases even hardware, because QEMU is an emulator and not a virtualizer. So if you want my credentials, I was doing work like this 10 years ago, making it work with things that still has a constantly growing fan base today, because these tricks have never been done better. There's nothing like it. You can Google up tiny Linux and things like it all you want. You're not going to find one that works like Linux. I've considered moving Linux over to Slackware and Tiny Linux and other versions, and it's all possible, but Tiny Core Linux, TCL, has been the consistently proven best in combination with old, stable QEMUs. And these skills I developed a decade ago. That was building on top of my Amiga days, right? So the Amiga was almost Unix. Top OS, right? I mentioned BCPL. The same Brit who created BCPL in Cambridge, UK, created Tops OS, and then Tops OS was very Unix-like, developed in 1976, a half decade after Unix made its debut. So it was pretty influenced by Unix by the time it came along. And the Amiga operating system, Amiga-DOS, Amiga OS, derived much of itself from Tops OS. So my favorite operating system, and here we're going back to, the Amiga came out in like 87, 88, but my personal history goes back to like 88, 89, going into college. Amiga might have came out 86, 87, right? So really at the heyday of Mohawk haircuts and Back to the Future, and when culture was classic that everyone's trying to be today, I got my true Unix experience with Unix-like commands, with Unix-like command line piping. It's arguable that Amiga was in many ways as Unix-like as Linux is Unix-like. You get it? You see? Right? I'm almost at my destination, so I wrap up here. And then before that, I was on the Coleco Atom. The Coleco Atom was certainly not Unix-like at all. And you could feel it. Everything, it wasn't quite as badass 8-bit as, say, the Amiga. Not the Amiga, as the Atari computers that came before it. The Commodore 64, I guess the BBC Micro you'd have to throw in there. All the stuff that inspired the Raspberry Pi. Upload. Hope you enjoyed this. Hope this put a lot of stuff in perspective. So I'm definitely constructing a Noah's Ark. I'm working on a Noah's Ark of tech. One of my attempts to do that was Linux a decade ago. It didn't turn out well, mostly for performance reasons, and the world was not ready for it. And artists become famous after they die. So I'm just creating my artwork, and when I die, people will look back and go, that Mike, he really had a thing or two right there back when he put together Linux. These are the principles that we all use in the modern age. All tech should be packaged to go. And now with containerization as made possible with LXD in particular, tech packaged to go is once again very possible, and once again very love-worthy, my friends. So MIKELEV.IN/UX. MIKELEV.IN/UX. Later, Gators.